Let us come to this theorem 1.4. Square root of 2 is irrational. This statement says square root of 2 is irrational. We all know that square root of 2 is equal to 1.41421356 going on like that. Non-terminating, non-recurring decimal. We learned already. So it is irrational number. But here we are expected to give a theoretical proof. If this theorem, theorem 1.4 is given in the form of a theorem, root 2 is irrational. They will ask you to prove root 2 is irrational. But at the same time, in our textbook, the proof of this theorem is just only to be taught and not to be asked in exam. It is not a theorem for which the proof need to be learned. But at the same time, what they will do, you can check in your exercise questions. They will ask you to prove root 5 is irrational. That is not considered as a theorem for them. That is just like a question for them. Okay. So anyhow you have to prove that one. It is exactly similar to proof of theorem 1.4 given in our textbook. Similar one. But it is asked as a question. And one of the frequently asked question in this chapter. It is a longer type question, a long answer, you can say. A 4 mark, usually the long answer carries a 4 mark question at us. So you have to give a theoretical proof why square root of 2 is irrational. Or now I am taking that, not taking 2 as irrational, 3 I take. Square root of 3, square root of 5, square root of 7. For everything you are going to use the same kind of proof. Nothing new, whatever they ask. Okay, let us take 3. Prove that square root of 3 is irrational. How you give a proof of this? You know, there is in mathematics, there is a kind of proof they are using. That proof they call proof by contradiction. What does it mean, contradiction? It's a very popular proof in mathematics. In some areas we are using proving certain thing, we use the proof by contradiction. What is proof by contradiction, you know? If you are going to prove root 3 is irrational, you should take it is rational. It is not irrational, rational you have to take. You have to assume like that. Then what you have to do, if it is a rational number, what will happen later on? You will take it as P by Q and taking certain thing. Later, what will happen? It will lead to a contradiction, a controversial statement which is affecting the mathematical fact. It causes a contradiction. If you show contradiction, then you will tell this assumption is wrong. Root 3 cannot be rational. Like that you will assume. Because if you assume it is irrational, something wrong, something wrong which violates the mathematical concept is going to happen. Some contradiction is going to happen. Because of that, you cannot assume root 3 is rational. Therefore, root 3 must be rational. Like that we conclude. This proof is called proof by contradiction. So the proof is by contradiction, as I told you. So what you do, you are assuming, let us take root 3 is rational. I take rational. Okay, then root 3 is rational means what kind of expression it is. So you take root 3 is equal to P by Q. Where P and Q are integers, Q not equal to 0. This is definition of any rational number. Okay, now I took P and Q are integers. Okay, see, a fraction in the sense, P by Q means the fraction may also be like this. See this one, 10 by 15. This is also a rational number. But there is a common factor for 10 and 15, that is 5. So I can simplify or divide by 5 in the numerator and denominator. I get 2 by 3. So simplest form become 2 by 3. So your 10 by 15 become 2 by 3. So if I take a rational number in the form P by Q, the numerator and denominator may have some common factor. Like that, here this P and Q may have some common factor. If so, if they have, they don't have, no matter. If they have some common factor, what we have to do? First thing, you have to simplify the fraction to the lowest terms. Means you have to divide the numerator and denominator p and q by some common factor. We divide, okay? Divide them by the, if p and q have some common factor, we divide them by the common factor and obtain a new fractional form, a by b. A by b, I got p by q became a by b after simplifying. How our 10 by 15 become 2 by 3? In the same manner. So p by q become a by b. What happens here? Now one important thing you are going to see here. Root 3, instead of p by q, I am writing it as a by b. This a by b is the simplest form of the fraction. There is no common factor for a and b, right? Because you simplify it. So now, if there is no common factor for two given number, you can call them as co-prime numbers. How do you call? Co-prime numbers. So here a and b are co-prime numbers because they do not have any common factor other than 1. So 1 is a common factor of any two number. I cannot say no common factor at all. 1 is a common factor, of course, but there is no other common factor. A and b do not have any common factor except 1. Therefore, a and b are co-prime. This statement is very important statement. This is only going to give the conclusion of your proof. Okay. So what we have to do? Should take you mark this statement as 1. Mark it as 1. A and b are co-prime. Root 3 is equal to a by b, where a and b are co-prime. Is that clear now? Alright. Next what you do? This b transpose this side. So a is equal to root 3 into b. So a is equal to root 3 into b we are getting. Okay. You will understand why we do all this later on. So a is equal to root 3b. Then what you do? Square both sides. Squaring both sides we get a square is equal to root 3 square b square. Root 3 square is 3. So a square is equal to 3b square you are getting. That also note it down as 2. Note it down as 2. Okay. Alright. Now look. So a square is 3 times b square. Isn't it? So what you can say? A square is a multiple of 3. Because 3 times something. 3 multiple of 3. Or in other words, you can say 3 divides a square. 3 divides a square. Because a square is a multiple of 3. So 3 divides a square. Okay, 3 divides a square means 3 divides a also. Where have we heard about it? This theorem. Theorem 1.3. If p divides a square, then p divides a also. A square is a multiple of 3. We entered here. 3 divides a square. Isn't it? So if 3 divides a square, 3 divides a also. From where we learned? Theorem 1.3. The prime number divides the square of something, it will divide the number itself. Like that, 3 divides a square means 3 divides a also. In other words, a is a multiple of 3. A is a multiple of 3. So what I do? Just I take a is equal to 3 times some number. What is that some number? C I take. A is equal to 3c. I take 3c. C is some integer, okay? Take in that way. That you take and substitute in statement 2. Statement 2 says a square is equal to 3b square. Okay? So in this place you substitute 3c. So what happens now? 3c the whole square is equal to 3b square. What is 3c the whole square? 9c square is equal to 3b square. Find out b square is how much? So if you find like that, b square is equal to 9c square by 3 if you transpose, and you are getting 3c square, cancelling 3c square. So b square is equal to 3c square you are obtaining. What does it mean? B square is a multiple of 3. 3 times something. So b square is a multiple of 3. In other words, 3 divides b square. 3 divides b square. Okay, again apply theorem 1.3 in this place. 3 divides b square. So 3 divides b also. 3 divides b also. Mark that statement as 4. Okay. Here you have already a statement marked. 3 divides a also. Now you got 3 divides b also. What does it mean? 3 divides both a and b. So 3 is a common factor of both a and b. We are getting like that. Here only we say this is a contradiction. What contradiction? What it contradicts exactly? We have initially taken a and b are co-prime. There is no common divisor for a and b except one. Already it is simplest form. Now what we brought? 3 divides a as well as b. Means 3 is a common divisor of a and b. We are telling. So this is a contradiction to our previous statement. So why this contradiction arises? Why this controversy arises? The controversy arises as I have assumed root of 3 as p by q or a by b. That is why this contradiction came. So what you conclude from that, this a cannot be expressed in the form p by q. Cannot be expressed. Root 3 cannot be expressed in the form p by q. Where p and q are integers, q not equal to 0, whatever it is. So if root 3 cannot be expressed in the form, what kind of number will it be? It will be irrational number. That is what the second definition I have explained to you in my previous video, that if a number cannot be expressed in the form p by q, where p and q are integer, q not equal to 0, then it is irrational. So in that way, root 3 becomes irrational because it cannot be expressed in the form p by q. This is how you will have to prove this. Just like the theorem, you have to prove. This is every time they ask this question in the board examination. So this type of question they can ask you, prove root 3 is irrational. In your textbook exercise if you see, they ask you to prove root 5 is irrational, root 7 is irrational, root 11 is irrational, whatever they ask you. You follow the same procedure, replacing root 3 by root 5 or root 7. Depends upon the question. Hope you understand this, right?